Hi everybody. This is the other AP Statistics question that you got on Thursday, February 18th, or I'm sorry, on Friday, February 19th, the day that I had the substitute. So this is question 2009 Test A, question number 2, and this is the one about the tires. So we've got a tire manufacturer who's got a new tread pattern. Repeated tests were conducted on cars of approximately the same weight traveling at 60 miles an hour. The tests show that the new tread pattern enables the cars to stop completely in an average distance of 125 feet with a standard deviation of 6.5. So what they're telling us is that mu, the average stopping distance, is 125 and sigma is 6.5 feet. Okay, so that's what they gave us. Question A says, what is the 70th percentile of the distribution of stopping distances? Okay, if we draw the picture of what this distribution looks like, the distribution of stopping distances is normal, because they tell us so right here, normally distributed. We want to find the 70th percentile. So we want to find that value that gets us a 70% left tail. Or in a probability statement, the probability that x is less than or equal to some value is equal to 70%. We've got to find that value. Okay, well, we can use a calculator to do it very quickly. We'll go ahead and look at the inverse norm function. The left tail area is 0.7. The mean is 125. Standard deviation is 6.5. And the 70th percentile is going to be 128.4086. So x is equal to 128.4086. And this will be the 70th percentile of the stopping distance. Okay? This is all your work. This is what you're showing. The graph, the probability statement, the answer. If you just write the answer, you will probably not get credit or not get full credit for what you did. Even though you're right, you got to show the work. Okay, please remember that. You must show the work. Okay, it's like magic. Here's part B. What's the probability that at least 2 cars out of the 5 randomly selected in the study will stop in a distance that is greater than the distance calculated in part A? Okay, so let's take a look. In part A, what distance did we calculate? 128.4086, right? Okay, so what we're looking at is if the sample size is equal to 5, what's the probability that x is greater than or equal to 2, where x is the number of cars, not cards, oops, number of cars that stop greater than 128 point whatever that was, 128.4086 feet. 0.4086 feet. Okay? It's a binomial situation, isn't it? We're looking for the probability of getting 2 or more successes, where a success is a car that stops in farther than 128.4086 feet. What's the probability of success, you ask? Right? It's equal to 0.3. Where'd that come from? Look at the last problem. They asked us for the value at the 70th percentile. That means there's a 70% chance that a car will stop in less than this distance and a 30% chance that it'll stop in greater than that distance. Okay? So the probability of 2 out of 5 cars that stops in a distance that is greater than what we calculated is a 30% chance of that happening. Okay? So the probability that we have at least 2 successes, yeah, remember I told you to do this, right? What are we looking at? 2 or greater. Okay? That's equal to 1 minus the probability x is less than or equal to 1. This is what the CDF function can compute, 0 and 1. Okay, so let me grab my calculator and let's shrink it up a little bit so we can see that. Okay, so oops, can't shrink it up. Okay, now we'll deal with it. Binom CDF. Okay. N is 5. Probability of success is 0.3. And we're looking for 0 or 1. So it's a CDF of 1. So our probability is, let's see, 0.52822. So 1 minus 0.5282. And that equals 0.4718. So that's the probability of getting at least 2 cars out of 5 that will stop in a distance greater than that 70th percentile distance that we just had. Okay, question C is a little bit tougher. You got B and C sound kind of the same, but they really aren't. Okay, take a look at, let me just flip back to B real quick. Part B says you're picking 5 cars. 1 car, 2 car, 3 cars, 4 cars, 5 cars. Pretend those dots are cars. We're looking for the probability that at least 2 of these 5 stop in that stopping distance that's greater than whatever we calculated, to 128.4 feet. Okay, this is 2 out of the 5. Question C says let's take a sample of 5 cars and let's look at the mean stopping distance. Okay, so what this is a sample of size 5, and we want to find the probability that X bar is greater than or equal to 130. You see, in problem 2, we were looking for the probability of X, where X is the number of cars that stop in greater than that distance. In 3, or in part C, we're looking at the probability that the mean stopping distance of the 5 cars in our sample is greater than 130. So we have to figure out what the distribution of X bar is. Okay? Well, X bar is normally distributed with a mean of 125 and a standard deviation of 6.5 over square root of 5. Okay? But wait, you say, what about the conditions and assumptions? We can't do this without the conditions and assumptions, and you'd be absolutely right. So if we take a look at conditions and assumptions, the condition is simple random sample. Okay? That is stated in the problem. Do you see where? Randomly selected sample. We're also told that the population is normal. That's stated in the problem as well, because they tell us the stopping distances are approximately normally distributed. So that's stated in the problem. Both conditions are true. This is true. And now all we have to do is draw our picture, and we're going to get our answer pretty quick. 125. Sigma of X bar, the standard deviation of the sample mean, is 6.5 over square root of 5. And we're looking for the probability of being greater than 130 foot stopping distance. And so to look at the calculator with this, we're going to find normal CDF of 130 and a big number, and 125, and 6.5 divided by square root of 5. And there's our probability, 0.0427. Okay, so this probability then is 0.0427. And I can put a little note here, 0.0427. Okay, there's all the work for this problem. All right, make sure you show all the work. Don't just give them 0.0427, do it all in your head and on the calculator. That will not get you credit. Okay? So there is the third, or the other AP Stats question.